Morning, students. We're going to go over two questions really quick. You don't even have to write these down if you don't want to, but it's just two other types of problems that you could see that involve L'Hopital's rule. So let's take a look here at how we would approach a problem like this. So consider the differential equation. Right away, when you see dy dx, I want you to think slope. Right? This is our equation for slope. I can find it at any point x and y. And then it says let y equals f of x be a particular solution to the differential equation with the initial condition 0, -1. Well, what that tells me is when x is 0, y is -1. Now notice, if I wanted to, I could find the slope right away at this point. If I plug in 0 and -1, that would give me the slope. Which actually, I might do that. I have a feeling that's going to come into play. So, oops. All I'm going to do is take the derivative and plug in y is -1 and x is 0. So I get -1 squared, 2 times 0 plus 2. And that's equal to, let's see, -1 squared is 1. This gives me 2. So that tells me the slope at the function, which really this is the slope at 0. Right? So one thing you can kind of think of is when x was 0, this is the slope of the equation for that point. So that's a little side work, but let's get to this piece right here. So I want to find L'Hopital's rule, or I'm thinking I have to evaluate the limit. I'm going to think that this might be a L'Hopital's rule type problem. So I'm going to just take the original function. I'm going to put in the numerator. All right, now we're going to plug in 0. And now notice, we don't have the function f, but they tell us exactly what f of 0 is equal to. F of 0 is -1. So this part right here is -1. -1 plus 1 tells me the numerator goes to 0. Now I have to do the denominator. We're going to take the same limit as x goes to 0 of sine of 0 of x. Well, now I can just do substitution. Plug in 0. You hopefully know this one from heart, but if this is where 0 is, go over 1 up 0. Sine is the y value. So I end up with 0 over 0. My pen is not working well. Okay, so pretend that says 0 over 0. But that's our sign. We don't like that. Well, now we're going to apply L'Hopital's rule. What are we going to do? We're going to take the derivative of the top over the derivative of the bottom and apply the same limit. What is the derivative of the top? This is a really quick, kind of friendly derivative. It's just f of x. And on the bottom, the derivative of sine is cosine. So now, here's the way I'm thinking. I already know the cosine of 0 is 1. So I know that I can just do direct substitution, which is why I'm putting an equal sign here. I'm confident in this answer. Then I have to figure out what is the derivative of x at 1. Oh, sorry, at 0. I don't know why I put. I'm going to take the derivative of f at 0, because that's where our limit is going to, and the cosine of 0. So what is the cosine of 0? That's the 1 right here. And then what is the derivative of 0? We just found that. We took the point that was given, we plugged it in to find the derivative. F prime of 0 is 2. There is my limit. Okay. This is the work that you needed to show. If you skip any of that work, you're not going to receive full credit. All right, last one, let's take a look at a problem like this. This was actually, I think, from one of your assignments. I'm going to pause this so I can write out my work, and then it won't take as long. But we'll go over this in a second. Try it on your own right now. Okay, so I went ahead and did this problem just to save us some time. But what are we going to do? We're going to try L'Hopital's rule. I'm going to plug 0 into the top and 0 into the bottom and simplify. So here's the numerator. When I plug 0 in, I'm taking the limit of the numerator, plugging 0 in. I get e to the 0, which is 1, which ends up being 2 minus 2, or 0. So the limit of the numerator goes to 0. The limit of the denominator, when I plug in 0 here and here, I end up with ln of 1, which, remember, the natural log of 1 is 0, and then it's 0 minus 0. So when I compare numerator to denominator, we get the indeterminate form of 0 over 0. That's my ticket to do L'Hopital's rule. So then I'm going to do the derivative of the top. All right, and this is the part where you have to be really good at derivatives. So I'm taking the derivative of the top function. Notice the 2 is just a constant, e to the 3x. Well, the derivative of e to the 3x is itself e to the 3x. So I get 2 e to the 3x times by 3. The 3 is the derivative of the inside part here. That's the chain rule. And then minus 2, the derivative of that constant is just 0. And then the bottom part, and this is the part a lot of students end up kind of making a mistake on. The natural log. Now there's a chain rule here too. X plus 1 is on the inside. So I'm doing the derivative of the outside, which is 1 over x. But then we're going to keep the x plus 3, right, in the denominator. So 1 over x, or in this case, 1 over x plus 1. And then I am still thinking about, all right, what's the derivative of the inner part? And the derivative of x plus 1 is 1. So I did apply the chain rule, but sometimes the chain rule is just 1 and it doesn't affect it. And then I have the derivative of 3x to the third. Well, that 3 comes down, multiplies by 3, so I get 9x squared. So now I'm going to apply, and you could just plug in 0. That's what I end up doing. I know if I plug in 0 for x on the top, I get e to the 3 times 0, or e to the 0, which is e to the 0 is 1. So 1 times 2 times 3 ends up giving me 6 in the numerator. In the denominator, if I plug in 0 for x, I get 1 over 1, which is 1, minus 9 times 0 squared is still 0, so I get 1 on the bottom, and my overall answer is 6. All right, here's what we got today. My goal is for you to take the quiz and then work on any missing homework and turn that into Schoology when you're done. Good luck on the quiz. Have a great Wednesday.